Good day everyone, my name is David Rebancos of BSIT 21. The topic I will discuss is shortest remaining time first. So without further ado, let's go! Before we begin, let's define first what is shortest remaining time, also known as shortest remaining time first or SRTF. Is a scheduling method that is a preemptive version of shortest job next scheduling. In this scheduling algorithm, the process with the smallest amount of time remaining until completion is selected to execute. Since the currently executing process is the one with the shortest amount of time remaining by definition, and since that time should only reduce as execution progresses, the process will either run until it completes or get preempted if a new process is added that requires a smaller amount of time. Shortest remaining time is advantageous because short processes are handled very quickly. The system also requires very little overhead since it only makes a decision when a process completes or a new process is added. And when a new process is added, the algorithm only needs to compare the currently executing process with the new process, ignoring all other processes currently waiting to execute. Like shortest job next, it has the potential for process starvation. Long process long processes may be held up indefinitely if short processes are continually added. This threat can be minimal and process time follow a heavy tail distribution. A similar algorithm which avoids starvation at the cost of higher tracking overhead is highest response ratio next or HRRN. Advantages of SRTF. The main advantage of SRTF algorithm is that it makes the processing of the job faster than the SDF algorithm. Mentioned its overhead charges are not counted. Dis- Disadvantages of SRTF. In SRTF, the context switching is done a lot more times than in SDN due to more consumption of the CPU's valuable time for processing. The consumed time of CPU then adds up to its processing time, which then diminishes the advantage of fast processing of this algorithm. In this slide is the simulation of the SRTF. But before we begin, let's define first what is burst time or BT and arrival time or AT for those who don't know. So please bear with me. Burst time is the amount of time required by a process for executing on CPU. It is also called as execution time or running time. Burst time of a process cannot be known in advance before executing the process. It can be known only after the process has executed. Arrival time is the time when a process enters into the ready state and is ready for execution. So let's go into simulation. As you can see, there is 3 rows and 3 columns that can and the 3 rows contains the process, burst time, and arrival time. And for the first column, there is the process 1, process 2, and process 3. And to the next column, we can see the burst time. The, the burst time of process 1 is 7. The burst time of process 2 is 3. And the burst time of process 3 is 4. And to the next column, we can see the arrival time. For the process 1, it is 0. For the process 2, it is 1. And for the process 3, it is 3. In the previous slide, you see there are numbered 0 to 14 and contains the P1 and P2 and P3 and so on. So here's the explanation. At the 0th unit of the CPU, there is only one process, that is P1. So P1 gets executed for the one-time unit. At the first unit of the CPU, process P2 arrives. Now the P1 needs 6 more units more to be executed, and the P2 needs only 3 units, so P2 is executed first by preempting P1. At the third unit of time, process P3 arrives, and the burst time of P3 is 4 units, which is more than the completion time of P2, that is 1 unit. So P2 continues its execution. Now after the completion of P2, the burst time of P3 is 4 units. That means it needs only 4 units for completion, while P1 needs 6 units for completion. So this algorithm picks P3 above P1 due to the reason that the completion time of P3 is less than that of P1. P3 gets completed at time unit 8. There are no processes arrived. So again, P1 is sent for execution and it gets completed at the 14th unit. For those who didn't quite catch the explanation about the simulation in the previous slide, here in this slide, I put the explanation so that you can read it and take more time to process it and to know what is happening on the CPU. In this slide, we will calculate turnaround time, completion time, and waiting time. So we can see there's a table which has 6 rows and 3 columns. It contains the process, arrival time, burst time, completion time, turnaround time, and waiting time. For the process 1 or P1, arrival time is 0, burst time is 7, completion time is 14. To get the turnaround time, we will subtract the completion time to arrival time. So the completion time of P1 is what again? It is 14 and the arrival time of P1 is 0. So 14 minus 0 is equals to 14. Waiting time. To get the waiting time, we will subtract the turnaround time to burst time. So what is the turnaround time of P1? It is 14, right? So 14 and the burst time of P1 is 7. So 14 minus 7 is equals to 7. Now we go to the next. P2. Arrival time is 1. Burst time is 3. Completion time is 4. So to get the turnaround time, it is the same as always. Subtract the completion time to arrival time. The completion time of P2 is 4. The arrival time of P2 is 1. So 4 minus 1 is equals to 3. And the turnaround time of P2 is 3. So to get the waiting time, turnaround time minus burst time. The turnaround time of P2 is 3. So we will subtract it to the burst time, which is 3 also. So 3 minus 3 is equals to 0. Now to the last process, P3. Arrival time is 3, burst time is 4, completion time is 8. So we will subtract it again to get the around time. The completion time is 8. We will subtract it to the arrival time, which is 3. So 8 minus 3 is equals to 5. So the waiting time is, we will subtract the turnaround time to burst time, which is 5 minus 4 is equals to 1. Remember, to get the turnaround time is completion time minus the arrival time. And to get the waiting time is equals to turnaround time minus burst time. Average waiting time is calculated by adding the waiting time of all processes and dividing them by number of processes. And average waiting time is equals to waiting for all time of all processes divided by number of processes. So in this example, the average waiting time is 7 plus 0 plus 1 is equals to 8 divided by 3 because there are 3 processes. And now it is equals to 2.66 ms.
Hello everyone, this is Andrei Valenzuela from BSIT 21. In this video, we will talk about the round-robin CPU scheduling, including a brief explanation of its definition and how to simulate one. First thing we should know is what exactly is CPU scheduling. CPU scheduling is the method by which threads, processes, or data flows are given access to system resources. The primary objective of CPU scheduling is to ensure that as many jobs are running at a time as is possible. There are multiple types of CPU scheduling algorithms, but in this tutorial we'll mainly focus towards round-robin scheduling. What exactly is round-robin scheduling? Round-robin is one of the preemptive algorithms employed by process and network schedulers in computing. As the term is generally used, time slices are assigned to each process in equal portions and in circular order, handling all processes without priority. Round robin scheduling is simple, easy to implement, and starvation free. There is a term TQ or time quantum, which is the amount of time share give to each process, interrupting the job if it is not completed by then. There is also request queue, which is the order by which processes arrive and are handled. In this given example, there are 5 processes that need to be handled and the time quantum given is 3 seconds. So before we start, every time a process arrives, we have to put it in the request queue according to their corresponding arrival time. First, the process P1 arrives in the CPU and is primarily first to be put on the request queue. So P1 or process 1 is executed from 0 to 3 seconds since the given time quantum is 3, even though the burst time is 5. Given by that, there are only 2 seconds left for P1. Within 3 seconds, P2 and P3 has arrived in the CPU, so we put both processes in the request queue. But since P1 has not been fully completed, it still has some remaining burst time left. We have to queue P1 again and execute it in certain time. Next in queue is P2. We can execute the process for 3 seconds, so as from 3 to 6. And now the remaining time left for P2 is 0, meaning that the process is completed and doesn't go back on queue. Within 6 seconds, we have P4 and P5 arriving in the CPU. Then we put both processes in the request queue. The next priority in the queue is P3, so we execute the selected process from 6 to 9 seconds, which leaves P3 with the remaining time left of 3. Since P3 has not been fully completed, we put it back in queue to execute it another time. Next in queue hits the rearranged P1 to execute, but this time it will only take 2 seconds to finish its remaining time left, taking from 9 to 11 processing P1 completely. Up next, we have P4 in queue, so we execute that only for 1 second because only has a burst of time of 1. So process P4 is from 11 to 12 and is already completed. Next in the queue is P5. So we execute P5 for 3 seconds which takes from 12 to 15. This leaves P5 with total remaining burst time of 1. So it is assigned to go back on queue to be executed another time. Next in queue, we come back to the rearranged P3 and execute it again for 3 seconds, taking the process from 15 to 18 and completing the process because P3 has only 3 seconds burst time left. In final stage of queue, the queue encounters P5 with the remaining burst time of 1 second. So we execute P5 for 1 second only, which takes from 18 to 19. And that is how you basically simulate a round robin scheduling algorithm. I hope you learned something.
Good morning everyone, my name is Bernardo and Romano Jr. and my topic for today is shortest job first. What is shortest job first? Shortest job first is an algorithm in which the process having the smallest execution time is chosen for the next execution. This scheduling method can be preemptive or non-preemptive. It significantly reduces the average waiting time for other processes awaiting execution. There are two shortest job first. This is non-preemptive and preemptive shortest job first. Advantage: shortest job first is frequently used for long-term scheduling. It reduces the average waiting time over FIFO algorithm. Disadvantage: job completion time must be known earlier but it is hard to predict. This algorithm may cause very long turnaround time or starvation. It leads to the starvation that does not reduce average turnaround time. Example of non preemptive shortest job first. As you can see, there is no arrival time. So we must assume that the for process arrive at time 0. So time 0, i-analyze ng CPU yung burst time from shortest to longest. So as you can see, ang pinamababa is P4. So mauna siyang may allocate sa CPU. So 0 plus 2 equals to 2. Next na pinamaliit is P2. So 2 plus 3 equals to 5. Next is P3. 5 plus 6 equals to 11. Sunod si P1. 11 plus 21 equals 32. So, ang kukunin natin ngayon is ang average turnaround time. So, para makuha yun, kukunin natin yung turnaround time. Ang formula ng turnaround time is time finish minus arrival time. So, since wala nga tayong arrival time, ima-minus natin siya sa 0. P1 equals to 32 minus 0 equals 32. Sa P2, 5 minus 0 equals 5. Sa P3, 11 minus 0 equals 11. Sa P4, 2 minus 0 equals 2. So, kukunin natin yung average turnaround time. I-add lang natin lahat, then divide kung ilan yung processes, which is 4. So, 32 plus 5 plus 11 plus 2 divided by 4 is equals to 12.5. Next natin kukunin is yung average waiting time. Para makuha yun, kunin muna natin yung waiting time. Ang formula ng waiting time is turnaround time minus CPU burst. So dito, sa P1, ang 32 minus 21 equals 11. Sa P2, 5 minus 3 equals 2. Sa P3, 11 minus 6 equals 5. Sa P4, 2 minus 2, 0. Kung natin yung average waiting time, same lang siya ng average turnaround time na kailangan mo i-add lahat ng waiting time then divide sa 4. 11 plus 2 plus 5 plus 0 divided by 4 is equals to 4.5. And that's all for my report. Thank you.
My name is Russel Campillo. My topic is first come first serve algorithm. What is first come first serve algorithm? This non-preemptive scheduling algorithm, jobs are executed on first come first serve basis. Advantage: easy to understand and implement. Disadvantage: poor in performance as average waiting time is high as the convoy effect. Now, as you can see, we have the given example of the first come first serve basis. We have a 3 processor and meron siyang arrival time, burst time, at nakikita nyo naman na wala pang value itong starting time, waiting time, finish time, tsaka turnaround time. Para makuha natin yung value na yan at masagutan din tong nasa baba is kailangan muna natin sagutan tong Gantt chart. Ang gagawin natin is titignan natin tong given na value yung sa processor, arrival time, tsaka burst time. Una yung titignan is yung arrival time ng processor number 1. Isusulat natin tong 0 dito. At sumunod naman is dito sa loob yung processor na nauna. Ang sunod naman is yung burst time. Nalagay natin sa dito kung anong oras natapos yung pag-process. Lalagay natin dito is 12. Sumunod naman dito ay yung sumunod na processor. Process 2. And sumunod, burst time ng process 2 is 6. 6 plus 12 equals to 18. Sumunod naman is process number 3. And ang burst time ng process 3 is 9. 9 plus 18 equals to 27. Then, meron na tayong natapasan natin tong Gantt chart. Ang sisimulan na natin is tong starting time. Para makita natin yung sagot dito sa starting time, ay balikan natin tong sa Gantt chart. Kung ano yung starting time ng bawat processor, ay yung ilalagay natin. Sa process number 1, 0 ang starting time. Nakalagay natin dito, 0. And sa process number 2, ang nauna dito is 12. Kaya ang starting time ng process 2 is 12. Dito naman sa process number 3, ang starting time niya is 18. Kaya lalagay natin dito sa table is 18. Sumunod naman sa waiting time. Bago natin makuha ang waiting time, kailangan muna natin gawin yung formula. At ito ang formula. Waiting time equals to start time minus arrival time. Ang start time ng processor number 1 is 0 at yung arrival time niya is 0. Bali, 0 minus 0 equals to 0. Processor number 2. Ang start time ng processor number 2 is 12 and yung arrival time niya is 1. Kaya 12 minus 1 equals to 11. Processor number 3. Ang start time nito ay 18, tapos ang arrival time naman ay 4, kaya 18 minus 4 equals to 14. Ang finish time. Balikan ulit natin yung Gantt chart. Sa bawat process, sa pag-process ay meron niyang finish time. At dito yon sa may kita. Kaya ang process number 1 is 12. Ang process number 2 is 18. Process number 3 is 27. At dito na tayo sa last na kukuha natin ang value. Ang turnaround time naman ay kailangan din natin gawin ang formula na finish time minus arrival time. Ang finish time ng processor number 1 is 12 at yung arrival time niya is 0. Kaya 12 minus 0 equals to 12. Ang processor number 2 naman ay finish time ay 18 at arrival time is 1. Kaya 18 minus 1 equals to 17. Ang sumunod naman is sa processor number 3. Ang finish time niya ay 27 at ang arrival time niya is 4. Kaya 23. Natapos na natin tong table sa taas. Ang dito naman is yung average waiting time. Para makuha natin to, meron na tayong value dito sa waiting time. Ang gagawin lang natin is add natin tong value at divided by 3 kasi tatlong process yan. Kaya divide by 3. 0 plus 11 plus 14 divided by 3 equals to 25 divided by 3 is equals to 8.33. Ang turnaround time naman is meron na rin tayong value niyan dito sa taas, which is 12, 17, tsaka 23. The same din divided by 3. Kaya 12 plus 17 plus 23 divided by 3 is equals to 52 divided by 3 is equals to 17.33. At doon lang nagtatapos tong example ng first come first serve basis algorithm.